Everyone. Hello, everyone. Good morning, and I'm Maya Budimir from InoSens, Serbia. On behalf of the DIONE Project, we are welcoming you to this DIONE Workshop that is dedicated firstly to the promotion, of course, of the project, but mainly to project results. And DIONE aims to develop an integrated observation-based toolbox for modernizing CAP area-based compliance checks and assessing of respective environmental impact. The project is funded by European Union's Horizon 2020 Research and Innovation Program. Here, InoSens is a partner from the consortium that is responsible for the exploitation, communication, and dissemination of the DIONE project. I will introduce you, of course, with all participants who are partners of the project as well. Here today, the technical partners will present you more deeply the results of the DIONE project so far. And a year ago, we actually had the first event dedicated to the business prospects of the DIONE. And now this is the second DIONE workshop. Will be dedicated to the first results. So here, before the introduction of each partner, I want to ask my colleague Nemanja from InoSens as well to share the first poll that is going to be circulated among all participants. Please, Nemanja.
Yes. Thank you. Thank you, Maya. I will now put the poll questions that we are willing to ask you before we start with presentations. We will start with the general questions regarding the, let's say, some general questions regarding the tools that you are already using. So the first questions, I believe that you are all see the screen. The first question is, how much money do you spend in a 1-year period to pay for any kind of support software service or some kind of supporting tool? So it's 0 to 2,000 euros. The second is 2,000 to 20,000 euros. And then we have 20,000 to 100,000 euros, and then more than 100,000. The second question is, what are the main pain points, challenges, or needs in your business? Provision of crop type maps, moving harvest, plugin marker maps, geophysical parameters of crops, non-productive EFA maps, permanent pastures map, farmers geotag photos, ortho imaginary from drones, quick physico-chemical topsoil estimations, map of soil degradation indicators, and the last one is the environmental compliance report. We put all of these following choices in order to have the better results, and we believe that all of these things are related to our project and are important for us to see. And the third question, the last one, what are the current costs of field check per on-site visit per farmer, average? Please select one of the following choices. Less than 100 to 300 euros, and more than 300 euros. So we will wait a little bit more. We have 30 answers by now. We will wait for about half a minute. I see the answers are growing. 33 is now submitted. $35, so we'll wait for a bit. All of these questions are, as I said, general. We will have at the end of the workshop and presentation, we will have the question more related to DIONE, strictly related to DIONE. So your impression after the presentations, your opinion, all the participants can raise hand to ask questions to the partners. So we like to make it as much interactive as possible.
Nemanja, I think that it's time for you to share the results.
Okay. I will now end the poll. I see that. Please submit your questions. I see 45 out of almost 100. So I will now end poll. So 5 seconds. 4, 3, 2, 1. Okay, ending. So we see the most of the questions is 2,000 to 20,000 euros to spend for the some kind of supporting tool. What are the main pain points? You see the results here. Provision of crop paths, moving, harvest, plugging, marker maps are most of the answers. And current cost of field check, we see that it is or above 100, below 100, sorry, and 100, 300. So I will stop sharing and we will start with the actual presentations.
Okay, thank you, Nemanja, and thank you all for this participation, this short introduction. Before I present my colleagues, my partners of DIONE, just want to say we want to highly motivate you to interact here with us, and after each presentation, after each session, you're invited to, of course, to share your impressions, your feedback, or to ask a question, any question you are interested in, or to share your questions via chat. So, but firstly, please just raise a hand, and Nemanja will let you talk or let you ask a question. So our first presenter is actually Valantis Siakos. He's coming from ICCS, Greece, and actually the coordinator of the DIONE project. So Valantis, please start. Thank you.
Thank you. Thank you. Hello, everybody. Also, I would like to welcome you from my end in the context of this online workshop that is meant to present what we have achieved so far in the context of this Horizon 2020 project. So allow me, Maya, can you give me access to present? Okay, yeah, I can share my screen. Okay, hopefully you can all see my screen. So yeah, DIONE, as I said, it is an Horizon 2020 project that aims to implement an integrated Earth observation-based toolbox in order to modernize the common agricultural policy area-based compliance monitoring chains, and at the same time we assess also the respective environmental impact of the regulations in the different areas. So The project is coordinated by by the Institute of Communication and Computer System, and particularly our group, the iSense group of ICCS. So we have a multidisciplinary consortium involving 2 paying agencies from Lithuania and Cyprus, SMEs, Sinergise, GILab, Core, and InoSens, with a strong orientation to the Earth observation domain, the ICT fields, and the agricultural domain, and also to research institutes, us and i-BEC, that we are also working on technical elements around the project. So the duration of this project is 30 months, and we have received funding of approximately 2 million euros. And you can see here how we are spreading across Europe our team. So essentially, I will just give an overview about what you will see also in the presentations to follow. So the concept of DIONE, it is structured around 3 main components. So we have the Earth observation component that involves all these, I'm sorry, all this information and maps that we can derive from Sentinel, but also from other aerial means like drones, how we can exploit this information and couple them with machine learning and data fusion techniques in order to receive improved products like crop type maps or EFA or maps of the ecological focus areas, and so on. Additionally, we have the so-called in situ component that involves the implementation of a geotag photos framework, and also another part involving in situ soil scanning system that allow us to select information about the soil health and quality at the areas of interest, and a product data management infrastructure around it. And finally, the last one, it is the green accountability component that allow us on the one hand to exploit all this information coming from the previous components in order to assess, let's say, the compliance of the applicants, of the farmers in the areas of interest with respect to the green rules, and also an environmental performance tool that it is included there that allow us to visualize implement and visualize different indicators related to the environmental status of the areas that we monitor. So just a brief overview, a brief presentation about what you will see also in the next presentation. So the first part is what we call the Earth observation-based area monitoring system. That we apply a marker-based approach, exploiting Sentinel signals towards identification of various crop types, land types, like ecological focus areas, or the detection of agricultural activities that take place during the growing season. So different various markers are implemented to this end, and I will discuss more. But key innovations that we would like to point out here, it is our emphasis also to address issues coming with small unallocated parcels that we see in the region, and also to improve the resolution of the results through data fusion and machine learning techniques. Also, one of the other points of information here, it is related to the drone platform that is implemented that allow us to do targeted flights at areas of interest, collect very high resolution data, and utilize this in the context of the Earth observation-based area monitoring system in order to be able to detect different features of elements in the parcels, and be able also to upscale this at wider areas in the regions. Moving forward to the in situ component, we have a geotag photos framework that allows interaction between the paying agencies and the farmers towards collecting additional evidence for their parcels in the cases where we have conclusive information. Different features are being provided by the framework, like navigation to the different spots of the parcel for the collection of photos. It is based on augmented reality, so as to lend proper guidance of the user in the acquisition of photos, and other features related to security, like digital signature schemes, time and location integrity, and anonymization of the of any private data that might consist in the photos. Further to that, we have a portable in situ soil scanning system that has been implemented. So we are using low cost and portable spectral sensors that allow us to record information in the field. And then this is associated with a mobile application that is connected with the spectrometer and allows us to collect spectral data that are properly processed, and we utilize them in the context of producing added value information through machine learning tools like soil properties, like soil organic carbon, clay, pH, and so on. And by combining this information with observation imagery, we are able to deliver spatially explicit maps for the areas of interest. Further to that, as I mentioned, all this information is being coupled in a compliance monitoring tool, as we said, that allow us to not only to manage the different information collected by the previous components, but also to visualize this information, to correlate this with parcels and GSA data directly coming from the paying agencies, currently in the project from Lithuania and Cyprus, and also generate data with respect to the compliance monitoring of the parcel for a given area, as well as interact with the farmers and request them to capture geotag photos at specific areas of interest. And last but not least, we have the environmental performance tool. The idea here is that we compute, as you can see in this table, different indicators so as to show the progress towards fulfilling the EU standards on good agricultural and environmental conditions of land. So this is a list of different indicators that we are computing, covering priorities for land and soil, for water, for air quality and climate change, and also for protecting the vulnerable areas in the regions. All this computation it is taking place through machine learning techniques and while exploiting open data available from Copernicus and other sources for the areas of interest. This is computed also for Cyprus and Lithuania, aiming to cover larger areas in the regions. And as I mentioned, these pilot activities are taking, our toolbox is being demonstrated along with two paying agencies, MPA, the National Paying Agencies of Lithuania, and CAPO, the paying agency of Cyprus, aiming to showcase real value in the context of their activities, not just for the compliance monitoring tool, but also with respect to reducing costs for the paying agencies, increasing the percentage of farmers interacting with novel technologies like geotag photos, and promoting the environmental performance in the context of the greenings in the areas of paying jurisdictions, and also facilitate this transformation that we expect to take place with the upcoming CAP. So, and essentially, this is the main goal. I mean, to be able to the main impacts that we foresee in the context of the project are oriented on being able to exploit different technological innovations in order to deliver value to the different client communities. This not only cover paying agencies, but also other actors like control and certification bodies, the agri-consulting industry, the earth observation industry, or other actors in the field that provide assistance and facilitate these processes in the agricultural domain, and allow to further gain knowledge from what we do in the project, and also utilize this information in the context of their contexts, and see how this can be fit and support them in increasing their efficiency and also their market proposition. Thank you. Thank you very much, and hopefully you will be able to learn more and find more information about each of these components that I described briefly in the context of the forthcoming presentations.
Thank you, Valentis. I just want to highlight here the fact that we actually include paying agencies beside these technical partners that are going to present you more the results of the project, but we include directly our target customers. And we are aware of the diversity of the user requirements, but we are here to develop the standardized solution that could be implemented within this diverse environment. So our next presenter is Nate Vessel from Sinergise, Slovenia. Nate, hello.
Hi, everyone. First, let me share my screen. Just a second. Can you see my presentation? Is it okay?
Yes.
Okay. Okay, thank you. So first, let me introduce myself. I'm Nate Vesel. I'm a data scientist and part of the research team at Sinergise, and we are responsible for the Earth observation component within DIONE. And so we're trying to use machine learning technology, some data fusion, and these super resolution techniques that were developed as part of the project to kind of put it together into an Earth observation-based agricultural monitoring system. So what is it all about? The idea is that we want to find the few bad apples, so the mismanaged claims or the erroneous claims within the features of interest in a country. And we want to do this through this marker approach. And the idea is to use the markers to actually find the good apples. So to find evidence of agricultural activity and try to confirm it basically in all possible instances. How do we do this? So we are relying on an object-based approach. So we don't do analysis on pixel level, but we take the features of interest, so the polygons, and we aggregate the signals and indices over this feature of interest to get kind of for each polygon a time series. And then we have the markers, which are kind of developed to work with the whole time series as input, or that work on some derivatives of this time series. So they can work on the single observation, or they can work on time window average, or they can work on the time window average and the average of the neighboring fields and so on. What we also strive towards is interpretability. So we also work towards so that the image chips or DOFs are needed for thorough interpretation of the marker. And it's also important that the time series that we feed to the markers are cleaned up. And this is kind of very important. And this is kind of the focus of the next sections. So we have markers for both cleaning the reference data noise and also for detecting ineligible use. So one of these markers that's very important in this approach is the outlier detection. So as you can see, I mean, in reality, when you look at the Sentinel-2 imagery across a certain feature of interest, you will notice a lot of outliers or a lot of clouds, cloud shadows, haze or snow on the field. And in order for markers to work well and for the time series to be kind of interpretable, this need to be filtered out. And in order to do so, we have developed a model that takes as input the raw bands, and it inputs whether the observation is valid or not. This is then combined also with our S2 cloudless cloud detector, and these two work together to clean up the time series of the noise. Then this is the noise on the observation level, but you also have noise in the claims. So you can have a claim which is claimed to be a single crop, but in reality, it's not correctly kind of delineated. And for this purpose, we have the homogeneity detector, which tries to detect such cases. This is also very important in this approach, because all other markers, or the majority of other markers that work on an aggregated FOI, kind of assume that the single crop is growing. And if this assumption is broken, then the results are not reliable. That's why the homogeneity detector is kind of needed. Then we have a very simple marker called the mean NDVI marker, which is used for detecting built-up claims. So in reality, it's very simple. You just take the mean NDVI of the feature of interest over a certain time period, but it has proven to be very effective in kind of detecting these lowest hanging fruit errors. So these are the FOIs which claim to be agricultural land, and they in some cases even get subsidy, but in the reality, maybe something was built up on them, or maybe it's completely bare and so on. So one simple marker that can solve a lot of problems. So these are kind of markers that try to detect errors or to try to detect outliers, but we also have markers for confirming agricultural activity, which is the end goal. So the first one is the plowing or the bare soil marker, which can be used to detect plowing events and detect harvest events. And this is used because obviously with satellite imagery, it is not possible to detect actual plowing or actual harvest, but we can observe the changes that happen on the field. And in this case, the change is that the field becomes bare and the bare soil detector is used. It's a simple, I think, decision tree model, and it can be applied, and it seems to generalize well across many areas. Similarly, as for the bare soil detector, for grass-like voice, it's important to detect agricultural activity in terms of mowing. So we've developed a mowing marker which looks at the drops in NDVI, which are above a certain threshold or above detected noise. And it can also be, and it detects drops and marks the mowing events when they happened. Obviously, so bare soil and mowing markers detect specific events, but then we also have the crop type marker and the similarity and distance markers that try to confirm the claimed crop type. The assumption here is that if the models confirmed what was actually claimed, then you can safely say that some agricultural activity has been happening because the crop is behaving as expected. So we have the standard model, so the crop type marker, which is kind of well known to everybody here probably. But we also have the similarity and distance markers, which are not machine learning models, but they are rather based on statistical techniques, and they try to solve a specific issue. So the crop type marker is maybe unreliable for crops which are not well represented in the data set, and it can also be unreliable when on areas which are maybe not standard for the whole country. And this similarity and distance markers work in a way that they take the feature of interest that you're looking at, and then they compare the NDVI time series of that to the neighborhood with the same claim. And the assumption here is that if the neighborhood behaves in the same way, then the claim is likely correct. And we try to exploit this to kind of confirm the results of crop type markers or to improve the results of crop type marker. Obviously, each marker on its own has some value, but I think the real value here comes when combining these markers into some custom business rules or decision trees. And this can be, of course, customized to suit the specific needs of each paying agency or if each client. The idea here being that the legislation changes, but so it is important to have a system that has the flexibility to easily adapt. So the markers stay the same, but they can be combined into different business rules and changed. We've run the process, we've applied this process to Lithuania, to kind of in a pilot way to Lithuania, and currently the process is ongoing on Cyprus. And at least in Lithuania, some results were already verified, and maybe my colleagues from MPA can comment more on that, but it seems that the results were of high quality. In addition to these markers, what we're also developing in the context of DIONE is also the super resolution techniques, and trying to combine what is developed within the super resolution to the markers. So one of the goals here is to enable agriculture in monitoring of smaller parcels in the context of the Common Agricultural Policy. And there's also the idea that super resolution techniques could help with non-productive EFA elements, which are often kind of small or elongated and so on. So as part of the project, we've gained access to very high resolution data over test areas in Lithuania and Cyprus. And this was mostly Deimos imagery and some Pleiades imagery. And basically, as super resolution, two different models were developed. So one was the super resolution that used VHR imagery. And this one, as input, was the Sentinel-2 RGB near imagery and the Deimos imagery at 2.5 meters. And the output is the 2.5 meter super resolved Sentinel-2 imagery. we've decided to use multi-temporal super resolution. So a temporal stack of Sentinel-2 images is used as input. And this was done so to exploit kind of misregistration errors and the temporal information that is derived from imagery. So this is one super resolution, and the other one was focused on, this one was developed by ICCS, and it was focused on upscaling the Sentinel-2 bands to 10 meters. So just to give you an idea, this is the idea for the model that uses VHR imagery. So we take the VHR and we take the temporal stack of Sentinel-2 and we try to derive super resolved Sentinel-2 imagery. And this is maybe an example of what the results look like. And these results were obtained for test areas in Lithuania and Cyprus. And this is an example of upscaling the Sentinel-2 20-meter bands to, 20-meter bands to 10 meters, and we can see like the original versus the super resolved, we can see quite a noticeable improvement. Some maybe as the last things, the preliminary results on this super resolution. So we've tried monitoring non-productive VFAs. And the problem here is that the large number of non-productive VFA polygons in Lithuania do not contain at least one full Sentinel-2 pixel. And that's why the super resolution here is kind of a nice addition, or is needed. And this allows us to actually monitor these parcels with good results. I think it's at around 90% accuracy. The question is what to do with the rest, and what we're currently exploring is, can the rest be monitored using a combination of drone and orthophoto imagery efficiently? And another ongoing activity which will provide some initial results soon is using upscaled Sentinel-2 bands within markers. So certain markers, for example, BERSOR or outlier detector, and so on, use in addition to the 10-meter bands of Sentinel-2, also use the 20-meter bands and the 60-meter bands. And the idea here is to check if using these super resolved bands to 10 meters can significantly improve the quality of the markers. And yeah, this is the focus of the next period of the project. And that's it from my side. If you have any questions, please let me know and I'll be happy to answer them now, or you can write me here on my email.
So thank you, Nate, very much. Nate presented to us the first component of the DIONE Toolbox, Earth observation component that was developed by, of course, Sinergise as well as ICCS. And you're highly invited to ask a question. Also, as an intro, maybe Nate could answer to us, as Sinergise did a pilot in Lithuania and Cyprus. What were some of the challenges that you faced and how did you solve them?
So I think the main takeaway from the pilots that we did is that it's very important to have good communication with the paying agency right from the beginning. So markers are a technical solution, but the problems are of a business nature. So I think it's really important to quickly figure out what the actual business needs are of the client. So in this case of the paying agency, and try to work together to combine the markers and to adapt the markers to what is actually needed by the client. So I think this was in Lithuania, the communication was very good, and I think this was nicely achieved. But maybe the colleagues from MPA can comment more if they're present.
Yeah, we have a comment from Oshius from MPA that the accuracy of most of the marker differs from 95 to 100%. So maybe he can comment here more.
Yes. Hello.
Hello.
Hello. Do you hear me and see me? Yes.
Yes.
Yes, so the accuracy is very high. It is between 95 and 100%. For example, the recent result from the variety areas for the BERSOR marker, but still needs don't know. But the result, what we get was 100%. That is really fantastic. And answering to Dominic's question, what is the added value compared to some cap algorithms? So we see that the better accuracy and the better results. So this is the answer.
Okay, thank you. If any participant have a question, please write on chat or be free to raise your hand. You can say it if you like.
Okay, if not, we can go further. I'm inviting Valentis again to present us now the second DIONE Toolbox component, in situ component. Thank you. Valentis, please.
Thank you. Maya, let me just find okay, hopefully you can see my screen.
Yes.
Okay, so hi again to everybody. I'm going to speak about another component, now moving from the Earth observation based area to the in situ components. And we're going to present you the DIONE Geotagged Photos framework. That it is an augmented reality-based framework that aims to complement the Earth observation-based analysis with reliable and ground-based parcel information provided by the farmers and the applicants. Okay, so we see that currently, the business scenarios that we see around this related to the usefulness for such type of applications in the context of small parcel-dominated regions, where we may have, as you know, inconclusive assumptions from the area monitoring markers, or we would like additional information for the farmers with respect to the status of their of their parcels. So the Geotagged Photos framework consists of two main components. The one part, it is essentially a mobile application that it is used by the farmer to capture photos supported by AR features, and the other one, it is a server-side process for the validation and integrity of the received information. Currently, we have implemented the alpha version of the component, and it is already available on Play Store. The component is integrated with the paying agencies in Cyprus and Lithuania through the GSA systems in order to be able to utilize already information about the parcels. And currently, we have more than 270 downloads since November 2021 from real users. So allow me just to give you a brief overview of the current steps in the application. So essentially, as I mentioned, the application is integrated with the paying agencies infrastructure. So the users can easily create an account, inserting details, some standard details that we have in application development, and also they can insert their applicant number and applicant ID, for instance, in Cyprus, or applicant number in Lithuania, and based on this, we are able to fetch related data from paying agencies infrastructure about their parcels, and they can, and by concluding the authentication process, they can log into the system and be able to visualize related content. Now here you can see some of the main application screens. Essentially here we have the first screens about the general page of the application, where there is a newsfeed part displaying the relevant information about related to the applicant. So the other part of the screen is related to open tasks. So here we have the possibility for the farmer to see what information is needed by the paying agencies and be able to reply accordingly, and also access to directions on how to use the app. Additionally, The application is harnessing GNSS differentiators, and we're performing certain checks that can be also viewed by the applicant with respect to the availability of Galileo Sigma, the ability of the device to support dual frequency for better results, check for EGNOS, and also for the Galileo navigation message check. Further to this, the user can see information about the different parcels. I mean, this information is coming directly from the paying agents infrastructure. Now, what you see is my test account. I think from a test site in campus. And additionally, one of the elements that we have introduced here, it is related to the communication with the paying agencies and the applicants. So as soon this is happening through push notifications, right? So as soon as we have a new request from the paying agencies about the acquisition of a photo about the parcel, this is being communicated directly to the applicant, and he is able to be an easy way to move to the respective parcel and perform this task. This is, for instance, an example how this would look like. Another part here, it is that around this logic is that it is apart from the tasks or requests that come from the paying agency, we give also the ability to the user to act proactively. I mean, there is also a free use functionality supported by the application, allowing the user to, by himself, to visit one of his parcels and provide additional evidence in order to support the process of its declaration. Without prior receiving a notice from the paying agency. And also this also can be viewed, also there is also task history that can be viewed also by, he can see his previous tasks and so on. So as soon as the applicant select a task, he can initiate it, the process, and there is a map navigation activity in place that allows him to guide him to the respective point on the parcel with instructions. And once the user reaches the needed location, he's able to activate the camera of his mobile device, and through an augmented reality environment, he's being guided, and through messages, he's being guided to the proper location where he needs to capture the photo. And at this location, he can also follow further steps and capture the photo at the needed locations of the area. After photo capture, he can visit the gallery of this of the mobile application, select the photos that he would like to upload, and easily transfer this information to the paying agencies. As you can see also here, I'm going to discuss this further later on. There is also an integrated component in place that makes sure that information, related information is being anonymized, private information, if it exists in the image. And I think I have also a short video to show to you. I don't know if it will be visible. This is from a testing activity that we did in summer. Now some features have been further updated since this early release of the application in summer, but just to show you a bit how the augmented reality feature was looking and looks like, I mean, in the context of the application. So here you can see how the augmented reality feature looks like in real conditions. So it allows you to navigate to the feature of interest, that it is located in the parcel. And also there are different messages that prompt you to, based on the instructions provided by the paying agencies. So in the current version of the system, we also give the user the application to the paying agency, the application to define also the orientation for the acquisition of the photo. Okay, let me continue in order not to fall behind schedule. So apart from this, apart from the user interface, what I was trying to mention also, I would like to mention also about this, it is that we focus to have improved also location accuracy when it comes to the application. This is happened through the exploitation of multiple location differentiators like dual frequency devices, and also we are investigating different methods with respect to the GNOS data access service for ground-based access to GNOS data through the internet, and thus improving further the accuracy in order to achieve 1 meter accuracy in the parcel. Now, further to that, some details with respect to the integrity. As we mentioned, the goal of the application, it is also to ensure the integrity and validation of the information coming forward. So essentially, we have included a lightweight digital signature scheme in the application. So this aims essentially that the first time during the authentication of the farmer, a unique pair of the private and public key is generated, and this is communicated to the system. When the farmer takes a photo, the digital signing takes place using the private key, and the signature is generated. The signature then, when the signature is produced, along with the photo, it is verified in the backend before being provided to the paying agency. Additionally, another mechanism that it is used to ensure the authenticity of the photo is the steganography technique. This technique uses the least significant bits of every pixel in order to embed a secret message in the photo that can only be extracted by using the reverse algorithm, and it is not identifiable by common tools. So, and this does not include any visual alteration of the photo. Further to that, another technique it involves aims to avoid digital manipulation of the photos, and this is the copy move forgery detection. So it is a process of copying and paste from one region to another location within the same photo. Here you can see also some example. So in case that the users attempt to do such alterations in the photo before applying this, we have implemented an algorithm that is based on principal component analysis. And we apply this process before, and we check the images before they're being communicated to the paying agencies. Also, we are verifying the time integrity directly by using the Android API, and based on this equation, we managed to recreate a near precise clock independent of the network access. And also for location integrity, we have implemented a module that is able to detect any external, let's say, processes or applications that try to alter the position or information of the GPS of the mobile device, such as spoofing attacks and so on. Further to that, a dedicated algorithm also has been developed, allowing the exploitation of the Galileo open service navigation message authentication scheme that essentially allows a GNSS receiver to verify the authenticity of the GNSS information and of the entity transmitting it. So then that we are sure that the navigation message received is identical to the message transmitted and that was generated by a trusted source. And last but not least, also we have this anonymization component that you saw also in the previous slides. We apply it is essentially a neural network that runs over the photos and is able to detect and blur personal information like faces or license plates that may exist in the image before these are communicated to the paying agencies. Thank you for your patience, and with this I conclude my presentations.
Thank you, Valentis. I can tell you that the geotagged application actually raised a lot of questions. So mainly, first concern is related to does this application work offline in the areas without mobile signal?
Yeah. I forgot to mention that also. Another feature. Yes, indeed, the application it works online. So the entire AR augmented reality feature can be supported and can work online, because we also know that this is the case in different areas. So essentially, the application, essentially the user would have, only to log in while having internet connection and send login the application, and then the rest of the process can take place offline.
Okay, great. Thank you. And the second question is there from Alexandra Sim, GRC. Is there a need for compass calibration prior to the first use, and how this process looks like?
Well, essentially, if you notice in the video, before I mean the generation of the augmented reality environment, we need some time for the user to wait, I mean a few seconds, in order to be able to assess, the current location information coming from the gyroscope of the device and the compass, in order to be able to reproduce as accurately as possible the generation of the environment. And this is a process that may last a few minutes. This is why, while you probably noticed in the video that the augmented reality environment did not, let's say, appear on the spot. We do some calculations beforehand in order to allow this generation and also subsequently the photo acquisition process.
Da bi obični, ajmo reći, eko-kokošinjac napravio da staka i žice pletene, moraš doći registrovati objekat.
Hello? Hello? There's one more question here on the chat. I don't know if you're looking at the chat, but for validation, do you check, for example, focal length to assure that there's an image taken of a photo held before the camera? Or is it possible to have audio signals to guide the user, and have non-IT user tested it?
Okay, thank you for the questions. Indeed, okay. So we did several activities when it comes to this process for camera identification. So in order to ensure that the origin of the photon, each user is paired with his mobile device. So this is achieved with a module that calculates the pattern noise and identifies the camera used to take the photo. The component of the camera that makes possible the identification, it is the CMOS image sensor that inserts a pattern noise in the photos, which is unique for each device. However, this can be challenging when you have AR features, in the application. So these characteristics of the camera cannot be imprinted in the photos, and thus the pattern noise cannot be computed properly. So to encourage this, indeed, we use the focal length, since it constitutes a fundamental characteristic of the camera. So indeed, very accurate comment. Now, with respect to the audio guidance, we haven't thought of it yet. I mean, how to do this. Currently, we are using messages inside the application, right, in order to guide the user about the location and so on. For instance, also if in case that tasks are communicated from the paying agencies to the farmers, from the inspectors, and they provide also details about the orientation that they want, or the type of the photo, it is a macro photo or a panoramic one, and so on, then these messages are appearing directly during this process. But indeed, audio guided, it would be guided with audio guidance. It could be something we further explore. And then the last question, yeah, indeed, currently the application is being tested by farmers in Cyprus, and we are ongoing process with farmers also in Lithuania.
Okay, thank you, Valentis.
Thank you.
If we don't have any more questions, we can continue. But first, I have to say thank you to our audience, because this kind of questions are very valuable for us and for the technical partners as well. So our next session, i-BEC partner from Greece as well, from Thessaloniki, and our colleague Konstantinos Kariotis is going to present you the second part of the in situ component of the DIONE Toolbox. Konstantinos, please.
Thank you, Maya. Good morning, everyone. I'm Konstantinos Kariotis from i-BEC. I have joined this call from Thessaloniki, Greece, and I'm going to present you the second part of the in situ component, which is a portable soil scanner that has been developed in the context of the DIONE project. Please give me a few moments to share my screen. First of all, a few words about the organization that I represent. We are a non-profit mission-oriented international organization linking local and regional communities. And our mission is to protect natural resources through the utilization of remote sensing and Earth observation data, and achieve stakeholder engagement through transferring knowledge from Aristotle University of Thessaloniki lab of remote sensing spectroscopy and GIS. DIONE's overarching objective is to establish a complete ecosystem of low-cost and easy-to-use smart tools for the farmers for the accumulation of the in situ information. These tools can be divided in two domains: the end-user domains that contains user-friendly interfaces which can be used by non-experts, and the back-end where all the data that collected are analyzed and converted to meaningful information regarding the soil. Our component is based on soil spectroscopy, which is a technique that allows rapid acquisition of soil information in the field or in the laboratory. Simply speaking, we hit the soil sample with a beam of light and we measure what bounces back. Depending on the composition of the sample, the energy that bounces back to the instrument differs from sample to sample, and thus we obtain the spectral signature of the sample. Here at the screen, there are some instances of different soil samples, the spectral signatures of different soil samples, which have different concentrations of soil organic matter. We can see that they have different shape, and the translation of this shape can give us very meaningful information about the quality of soil. We have different techniques to acquire soil spectral signatures. The one is remote sensing that involves spaceborne and airborne missions, and the other one is proximal sensing. Our component is based on proximal sensing, and it's a soil spectrometer that was developed to collect in situ measurements and provide quick indices, quick quality indices of the soil. The spectrometer that we developed has a range from 1750 nanometers to 2050 nanometers. It has a built-in illumination light, which consists of 2 tungsten vacuum lamps with estimated life expectancy for more than 40,000 hours. It is very small, it is portable, and it weighs about 160 grams. It has a built-in battery, which is rechargeable and can be connected with Android device. And can work on temperatures between 10 and 50 degrees Celsius. What can we monitor with this soil spectrometer? We have tested it over the soil organic matter, the clay, the silt, the sand, the calcium carbonate, and the pH. The region that it covers compared to the full visible and near infrared spectrum is the highlighted region around 2000 nanometers. For the usage of the spectrometer, we have developed an application which establishes a connection between the soil spectrometer and the Android device via Bluetooth. It can record and visualize the topsoil reflectance. It can capture a sample's photo. It can record the exact scanning location via the GPS built-in sensor, and can transmit the records to the DIONE's database management system synchronously or asynchronously. This is a very important feature because the device is intended to be used in situ, and there are many areas that do not have a very good internet coverage. So we need to be able to transmit our measurements on a later stage when we have made sure that the connection was reestablished. The application, as I mentioned, is a very simple application that enables non-experts to measure the condition of the soil. First of all, after creating an account, you can sign in. You need a white reference measurement. And then you are ready to scan the soil. You deploy the device on top of the soil, and in a few seconds, you have received the reflectance value. These values, this spectral signature through machine learning algorithm is converted to an estimation of soil organic matter or the rest quality indices. Behind this, there is a database management system where all data are collected. Through this database management system, we have a very useful information accumulated. And first of all, we see the white reference that allows us to check if the end user has performed a correct collection, a correct measurement. And then this is how the signal is transformed to reflectance. It is the division of the white reference measurement to the reflectance acquired in the field. And then through the machine learning models, this spectral signature is converted to the soil organic matter. And on the bottom, we can see the picture that the user has collected through the built-in camera that helps us make sure that they indeed visited the field, and according to the GPS location collected, we make sure that the data received are of high quality. Another useful visualization is that the map generated with the points visited from the end users. And since we are talking about modeling and converting soil spectral signatures to soil organic carbon, these are the results. We have a very good estimation over an independent set. These estimations are constantly increasing since we are constantly expanding our training data set. And these few outliers that we can see in the future will be closer to the regression line. And what we have made through the development of this component, we have increased the capability to monitor small parcel-dominated regions. This is a problem that has been, this is a common problem in Earth observation, that open access Earth observation imagery can cover only large-scale parcels. Of course, NEDS has proposed a very nice framework about increasing the resolution of Earth observation data. We are here to support this task. We quantify the current level of soil health and provide to end users dense temporal data in near real-time scale. As mentioned in the third slide, with soil spectroscopy, we acquire soil information with, let's say, the speed of light, while typical laboratory techniques may take a couple of days to produce the measurements. It provides a cost-efficient methodology for assessing soil health condition without expensive laboratory analysis. As you can imagine, since the models are built, the only thing that you are going to need is a soil spectrometer, and you will have very accurate estimations of topsoil properties. And the in-situ component is compatible with any Android device and easy to use by non-experts. I have also prepared a demo. I'm going to quickly share it in the chat. This is how you are going to use the soil spectrometer. And I will try to play.
Konstantinos,
Yes, yes, please.
will you share with us the demo, or you just share the via chat? So.
Okay, I have played the demo. I thought that I could share it.
No, oh no,
but,
it's okay.
But,
it's okay. You share it via chat, so our participants can see it. But
okay. Apologies, I thought that I was sharing my screen. Okay,
no.
Anyway, you're all invited to view this demo, and if you have further questions, you can contact me.
Yes, there is one question.
Yes, sure.
You may check it via chat. It's pretty long. So soil spectra is successful among other two, soil moisture and surface roughness, especially for proximity sensing. Have you thought of incorporating a camera in the device to document the conditions of the soil, for example, after plugging, rain, dry, flat? These images could be used to analyze the soil spectrum more thoroughly by identifying shadow, for example, components within the FOV of the spectrometer.
This is a very nice question and very explicit question. In the context of DIONE, we follow a different approach. We're testing a different approach that, not surprisingly, that has present very robust results. We have collected a big sample of a big set of soil samples, about 600 soil samples, and analyzed in situ and also in the laboratory. And then the laboratory analysis has been, for the laboratory analysis, the samples have been pre-processed, meaning removed all the moisture effect by air drying. They were crushed and sieved to obtain fine soil, fine earth. And we have developed a convolutional neural network, a deep learning machine learning model that transforms the in situ obtained measurement to the laboratory one. This transformation enables the user to remove the ambient factors such as soil moisture or shadows or any other scattering effect. And this model has present very, very nice accuracy of about an RMSE of about 3%. And we followed this technique. But the idea that, I don't remember the name, please, of Mr. Widlowski is examined since when we take a spectral signature, we monitor the environmental variables like soil moisture, and we include them in the machine learning predictive process. I hope that I answered, I covered you.
Thank you, Professor. And once again, I'm inviting you to check and to see the video because it's very demonstrative. And of course, you may contact Mr. Kostas via email. anytime or any of the partners. Okay, we can go. We can continue. Now we are coming to the third. Thank you. We are coming to the third DIONE Toolbox component, a green accountability component, and the first part will present us the Luka Glušica from GILab, Serbia. So Luka, please, the floor is yours.
Thank you. Thank you, Maya. Just a second to share my screen. Okay. So you see my screen, right?
Yes.
Okay. So as Maya mentioned, my name is Luka Glušica. I'm a senior front-end developer and geoinformatics engineer, and I will be speaking in front of GILab about compliance monitoring tool. Compliance monitoring tool represents a web application that consumes the data produced by other components of DIONE. And in order to provide an automated solution for deciding on beneficiaries' compliance to the green direct payment scheme rules. I will be doing a live demo of the tool by showing you paying agency inspector use cases and farmer use cases. So we can begin. This initial slide was just an introductory, and we can move to the tool itself. You see the screen, right? Because I'm not sure if I shared correctly.
Yes, it can be seen.
Okay, great. So before we start, it's important for each of the users to go through the registration process. In order for users to have access to the data from certain identification. For example, I will be showing on the Lithuanian case. They need to, for a farmer, for example, they need to provide applicant ID in order for a farmer to have the access to the data and to the platform. So that's one thing. Also, inspectors as well, they need to provide some kind of identification that corresponds to the one in their paying agency. So that's the condition, and once they're registered, they can access the platform through a simple login here. So I will be showing you, let's start with inspector in Lithuania. Okay, so as soon as inspector logs into the tool, this user gets the list of farmers that were assigned to him. We have two lists here. The first list represents the list of the farmers that are actually registered on the compliance monitoring tool. And the second list represent farmers that are not registered, but inspectors still can have access to their data, but cannot interact with them in terms of requesting geotag photos and anything related to DIONE functionalities that you already been able to hear about in the previous presentations. So if I want to inspect a farmer, of course, there's a search field as well. If you cannot find a farmer that you're looking for on the list, you can always search by his applicant number through this form and get the data for that farmer. So for example, I will select this farmer for inspection, and this view here is the main view of the application. Basically, we try to have everything in one place to make it as simple as possible. We don't want to overwhelm users with too much information at one place, but also we don't want to miss out on something. So this is the main view, and you have this map and loaded parcels on the map. Obviously, you can change layers of the map. By default, this is NDVI provided by Sentinel Hub, and you can switch between multiple layers, among which are also the markers which you've been able to hear about from colleagues from Sinergise. So let's start with showing one of the markers. For example, bare soil. As you can see here on the map, you can see that green represents when the bare soil actually occurred. So in order to see when that bare soil occurred, you can actually, just a moment, click on that parcel and wait for the response. So here you can see that bare soil happened exactly on these dates, as you can see here on the chart. That's one way of looking at that data, but I think that I will move to the most important part of this tool. That's actually the compliance report. Here you can see the compliance status calculated with the utilization of markers. And shut this down. We offer two possibilities. One is without markers, without crop markers, with using declared crops, and with markers by using the crops predicted by the crop type marker. Crop type marker is available also on the map. You can see it right here if you select a layer. And colors here go from red to green, showing the classification score of a certain crop. And if you zoom in, you can actually see the crop code and classification score, which means that this crop is predicted with high probability. Also, in the compliance report, you can do a crop type check to see if the crop is same as declared, predicted crop is same as declared, or if it's different, that's colored in red, in this case here. And if marker is not available, which is usually the case with small, really small parcels. I think that Nate could verify this, but I think that's the case. So basically we have for crop diversification and for ecological focus areas here the status. Of course, if you navigate back to the farmers list, we can see the overall status as well among this farmers list. And of course, if it's checked, then the farmer is compliant with the rules. If it's a question mark, then the decision couldn't be made due to, I don't know, lack of marker availability or lack of other relevant information. And the X sign is when it's not compliant. Of course, this is also showing without side what suits them. And of course, as you've been able to hear from Valantis, you can also, in order to request for additional evidence, you can request a geotagged photo from a farmer if you're, of course, inspector. So when you select a parcel for which you need additional evidence, send the request by populating this form, request a number of photos that you need from farmer, and of course,
so just one thing, I think that you're breaking a bit. I don't know if everybody else is has the same problem. It's we can follow you, but you're breaking.
Okay, maybe connection is a little bit unstable. I get that message here. Do you hear me? Do you hear me now without breaks?
Yes.
Okay. When you create a task through this form, it gets listed in the list of tasks here, and also farmer gets that in his list of tasks. And as well, we send a push notification to Geotag Photos mobile application so that farmers can upload their photos through that platform. Of course, when farmer uploads these photos are available on the map. Here you can visualize them, see some information about the photo, and decide if it fulfills the requirement. So you can mark this task as resolved if farmer fulfilled the request. So this is pretty much it from inspector part. We can move on to the farmer use case, which is a simpler one. Let me just log in for a second. Maya, let me know if I'm breaking or anything, because
Everything is okay now. I will let you know.
okay. So this is a farmer use case. It's different from inspector because farmer has access only to his farm, obviously, and has a restricted access to some data. We don't see that farmers will want to see markers. For example, they want to see their compliance status, obviously, and that's pretty much from the farmer use case. Of course, he has a possibility to see information about his parcel, or to check the vegetation graph, or see the photos if they're uploaded. And obviously, he can see the tasks created by inspector here with the status. So that's something that it's mainly related to read capabilities. So of course, there's a list of parcels which you can navigate. But one other thing that farmers have a possibility to do is to assign consultants to serve as a middleware between the farmer and paying agency. Through this form, basically, you can assign a consultant, and that's another user in the system that also users are able to register as consultants, and when he's assigned, he will have access to the farmer's data, which is also another feature of this tool. So this is pretty much it from my end. If you have any questions, I'll be happy to answer. So thank you.
Thank you, Luca. First, I want to remind our partners to open their cameras, just to show to the audience that the real people are behind these tools. And secondly, we have a question. On the chat, Mr. Jakub Todd asked, could be the legend color scheme customized? Not to be confused with traffic light scheme, green, yellow, red, or checks by monitoring?
Right now, no. Right now, we control the legend color ramp. But of course, if that's one of the requirements, it's not a problem to create another feature that would actually serve the purpose. So right now, it's not possible at this stage.
Okay, thank you, Luca. And one thing more, there's one more question. Mr. Widlowski, are there plans to automate the selection of points for geotech photos? Oh, this is based on the actual satellite analysis and the 8th claim of the farmer. I think this maybe Valantis also can join.
Yeah, well, I didn't hear about that plans, to be honest. Sounds very useful, of course, but we didn't have plans to make the automation. But of course, Valantis could also share his insights into this feature.
Yeah, so essentially what we evaluate at the moment is to give the possibility to inspectors of sending a batch request, you know, instead of visiting each farmer or parcel and creating a task. We are planning, I mean, subsequently in the update to give, we're discussing of having this batch request, you know, per parcel, in order to be able to alleviate a bit, let's say, the better in case of large areas, or in case of many users of the inspector of doing this and detailed process per user. We need to see if this would be of interest to the paying agencies to be automated completely. I mean, in the sense of deriving directly the output of the monitoring and deciding on this, because even in the case, you know, we automate the procedure of the result, but based on their experience, we see that the paying agencies may require to, despite that what we showcase as a yellow case, they may see that from the markers evaluation that we are depicting the map, that they can come up to a decision, so there will not be, let's say, a need for additional photos to be provided by the farmers. But indeed, this is a valuable comment, and we shall evaluate this and consider in the context of the next updates of our system. Thank you.
Thank you. Luke, I don't know if you check the chat.
I will answer. So there is no way at the moment to test the compliance monitoring tool from another agency, because as a part of the project, we are not only responsible for compliance monitoring tool, we are also responsible for the integration process between the DIONE Toolbox and the paying agencies. And that's a tricky task. And the goal of this project is to have to harmonize the data coming from paying agencies, and in order to keep our database consistent. And of course, one of the goals is also to make this integration process as flexible as possible, in order to be able to include more paying agencies in the future. So right now we are working with pilot areas and paying agencies from Lithuania and Cyprus as a part of the project, but in the future, the goal is to have a flexible solution in order to integrate any paying agency coming from Europe. So that's the idea for now, but at this moment, it's not possible to test that way.
Okay. Thank you, Luca. But also, just as one more additional comment, you already provided these guidelines in correlation with our paying agencies. Are you, or you just noticed that this kind of notifications could be useful for our target audience?
Sorry, can you repeat the question?
I mean, these guidelines that you made are actually the product of the collaboration with paying agencies, or you just noticed that the users find it useful?
About what question? Sorry, I cannot.
Okay, no problem. Can you hear me now?
Yes, I can hear, but I'm not sure I understand the question.
Okay, no problem. So did you see the additional question on the chat?
Yes, for easy way to test compliance monitoring tool.
Yes.
You refer to that. Yes, we are currently working with Lithuania and Cyprus, and we are trying to define the best way to integrate based on these paying agencies and their infrastructures. We're trying to find the most flexible solution to integrate the whole paying agency and their data into our system. And in order to allow another paying agency to register on our platform and test, we need to integrate them as well. And that's currently part of the project, to define that process of integration. So at this moment, it's not possible, but in future, the goal is to have an easy way to integrate any paying agency, and from outside, of course, the pilot partners and their paying agencies, of course. That's my comment.
Okay, thank you, Luca. We can we can continue the second part of Green Accountability Toolbox. Oh, there's one more question. Please, Luca, just check it. Luca, can you hear us?
Yes, just a moment to read the question. Is there an explicit check made in the system for the validity of the parcel declared that it corresponds to the one? Well, we check that by using markers. Maybe, of course, Nates can also intervene.
If I understand the question correctly, then the homogeneity marker is the most suited for this and is used for this. So the homogeneity marker checks whether what is declared is actually contains one single crop field.
Homogeneity marker is also available through the compliance monitoring tool as one of the layers. And yeah, maybe I didn't show it. We have a limited time, but it's also available to check through the tool visually and by clicking on the parcel as well.
Okay, thank you. As I mentioned, the second part of the Green Accountability Toolbox, the responsible partner for it is Core coming from Greece, and Mr. Georgos, please.
Thank you, Maya. Hello all. My name is Georgos Gotsis. I'm a front-end developer at Core Innovation. And just a moment. Okay, I believe you can see my screen now.
Yes.
Okay, great. So yeah, I will present the environmental performance tool as well as the visualization component of it. Okay. So what we are doing? So DIONE proposed a goal-based approach by introducing the concept of essential variables as an intermediate value between environmental CAP goals and the Earth observation sources. And the research methodology that we are focusing is on studying the interconnections between climatic and agricultural variables that are essential to develop 8 environmental composite indicators with regards to land, water, and air ecosystems. And what is the expectation of this is to use the selected indicators and show the progress towards fulfilling the European Union standards on the good agricultural and environmental conditions of land. So over here are the 8 performance indicators with a bit more detail on what each one represents. So we have the land cover change indicator that provides a qualitative and quantitative assessment of the change of land cover. We also have the organic farming that provides an assessment of the area under organic agriculture, the soil erosion indicator that shows agricultural areas affected by a certain rate of soil erosion by water. Then we have the soil organic matter that is used to determine the soil organic carbon concentration. And we have also the greenhouse gases emissions that monitor the concentration of methane, carbon dioxide, and nitrous oxide. The water quality indicator that monitors the chlorophyll concentrations as well as total suspended matter and water temperature. The land irrigation that is mapping irrigated and drainage areas. And finally, the Natura 2000 and the high nature values that provides information about the respective lands. over here is the overview of the indicators and their respective categories. So we have land and soil. That includes the land cover change indicator, the organic farming, soil erosion, and soil organic matter. The air quality and climate change indicator category that includes the greenhouse gas emissions, water, and protected or vulnerable category that includes the Natura 2000 areas. So yeah, that was the short presentation of the theory, let's say, behind the environmental performance tool. And now I would like to give you a demonstration of the visualization component of that. Just a moment. Okay. So can you see my screen again, right?
Yes.
Perfect, thank you. So let me quickly log in here. Okay. And here we have the main interface of our tool. It is composed of the map here in the center, which is used for navigating in the specific areas of interest among the use cases, the countries that we use for the project, Cyprus and Lithuania. Of course, this can be done manually by dragging on the map or by using the search box over here that can also accept free text as well as coordinates. And on the left side, we have the main menu that includes the select indicator component, which is a list of the available indicators. We have our date picker that can be used by the user to select the available year that they need to get information. The draw mode that enables the draw polygon functionality on the map to define the area of interest. And finally, we have some visualization modes for the map itself, such as dark, light, etc. So, having done that quick walkthrough of the interface, let's proceed with some examples and functionalities that our tool offers. I'm gonna start by selecting the land cover change indicator for the year 2020. By clicking on the draw polygon, the user can select an area of interest. And by clicking apply here, sends a request to our backend. And then we get back the available information for that defined area. Now, at this time, we only have the land identification component available, but in the final version, this will include also how the land changes over time. So as we can see here, we have our legends. In this case, can you hear me? Because I see some.
Yes, I can hear you well. I don't know about the rest of the audience, but.
Okay. Okay. I thought that my connection got corrupted. So, as I was saying, on the legend over here, we have the land identification along with the percentages within the area of interest. And the user can hover over that area and can see the description. In this case, the cropland. This is the cropland area that is about 5% of the whole polygon. And again, let me select another indicator. Let's do the land irrigation over here. Now, of course, you can just pick a different indicator and keep the same polygon defined, or you can just reset and draw another one. It's the same thing by clicking apply. Oh, no, this is a tiny percent. As you can see here, this is the only part that the model detected as non-irrigated. It's the 0.12% of the whole area. So maybe I can do something, another area maybe. Let's. Okay, much better. So yeah, again, on the legend over here, we have the irrigated and non-irrigated lands, as well as the coverage of the whole area. And let's have a look at the water quality indicator. We'll select the chlorophyll as our unit, as our metric. So we have a legend over here with the values. And again, we have a hover functionality, so the user can just hover over an area and check the corresponding value of the chlorophyll concentration. It's the same for the suspended matter, again with a hover and the legend, the hover functionality. And same again goes for the temperature. And let's do the final one, the soil erosion. Okay, this indicator shows us the erosion in the area. As we can see here, it's low. And I guess, yeah, I see that we don't have much time actually. The other indicators are with static information, so that's why I'm not showcasing them. I can do maybe just one, the greenhouse gases one. Let's say that we want to see the concentration levels of nitrous oxide for the country of Lithuania. By clicking apply over here, the data are fetched, and you can see this graph with a monthly concentration for nitrous oxide from years 2017 to 2020. So yeah, that would be all for me. Any questions? I'd be happy to answer.
Okay, thank you. Thank you. Maybe I'm inviting you to, of course, to ask a question. And but what I can ask something. Maybe what is the maximum area that is covered by the indicators?
Right. Yeah. So we are covering nationwide. It's all the indicators covered nationally. The areas of Cyprus and Lithuania. So
is it possible for each country also to cover the whole area?
That could be possible. Yeah, depends actually on the data size, but yeah, the solution is scalable. So yeah.
Good. I think it's valuable information. We have one question: how erosion and nitrogen to oxide are calculated?
Okay, so the nitrous oxide, it's from the greenhouse gases indicator, correct? So yeah, these are static data. We have just imported the data that we got from where we got them actually. Yeah, actually, yeah, I don't want to say something because I can't think of it at the moment. So yeah, both those questions should be, if you want, you can send me an email and forward it to my colleague, Ioannis Livieris, that is responsible for the machine learning component of the tool. So he can answer them correctly, because I don't want to say something that is inaccurate. So if you could please, I can share my email on the chat. So any questions regarding that, you can send me an email and I will forward to my colleague.
Okay, please do. Thank you. I think we don't have much time left. And thank you once again for this beautiful demonstration, even though there's no time, but I think that it was very valuable to our audience. I would say that we come into an end, and that we can say that from our side we are very satisfied. But first, before the end, one short poll that we already introduced. So, Nemanja, please.
Thank you, Maya. I will share with you, with all the participants, the last poll that we have for you. According to what you heard in the previous 2 hours, we have 3 questions. First question is, please specify the DIONE component you would pay for. It's possible to select more than one choice, multiple choices. DIONE Earth Observation component. The second one component is DIONE In Situ component, and third one, DIONE Green Accountability component. So please select 1, 2, or 3 of them, or none. Second one, how much money will you spend in a 1-year period to pay for the DIONE products? So this is the second one question. So how much money would you spend, not will, in a 1-year period to pay for DIONE products? There's 4 possibilities for you to choose. What kind of business model is the third question? What kind of business model you would like to be applied for the pricing of the DIONE Toolbox? The third one and the last question. We will wait for the all participants to take your time and read the question carefully and select the answer you see fit.
Okay, I can just say a few words before Nemanja will share the results with us. I want to say, to conclude here, that this workshop was dedicated to this direct communication with our target users, and we are aware that the user requirements not only of paying agencies but also of certification bodies and other DIONE stakeholders are very diverse, and this event served us as an opportunity to examine more your needs and your requirements. So, I think the time for poll is.
Sorry. My participants write on chat that the poll is not working, and I relaunched it. So now is available. So please wait 1 to 2 minutes for all to take a vote.
We also have some help from the audience that participants of the poll must be sure that have collected all 3 answers of the poll.
Okay, now it's growing, 28 answers. Please take your time. Of course, in the first question, you can select multiple choices. The second one is logically single choice, and third one is valid single choice. If you in the third question, if you want to select the option other, please type your answer on the chat. If none of the first one, service per hectare, service per unit of service, is not relevant to you, use the chat to answer on that question. Okay, thank you very much. As I see, about 1/3 of participants. Okay, we have here the partners. So let's imagine that the half of the participants participated and voted. Thank you very much. Some of the persons said, I will not vote as I do not want to respond as I'm not one of the target groups. Okay, thank you. Thank you for all. Maya, if you want to say something for the end, also the coordinator.
No, from my end, I think this is it. Thank you all for participating into this DIONE workshop today. Now you can see the results of the poll here. From my end, that's it. Thank you. Valantis, maybe you want to say the final note to the audience.
Yeah, thank you all for participating to this workshop. It was really nice to hear from you in the context of the poll, and also to be able to reply to your questions. I think after the meeting, after the workshop, all the material presented today along with the recording will be circulated to you. And also along with our contact details, we would be happy to answer more questions that you may have, as well as to explore more synergies with you. As you understand, this is an ongoing process. Currently, we validate our components into cadres, and we will be more than happy also to evaluate other opportunities of liaising with you in the context of your activities and try to see how the tools could be fit to your needs and to your business processes also in the future, in the coming months to come. So thank you again, everyone.
Exactly. We are highly inviting you to contact us or to organize meetings with us if you want to hear more about the DIONE Toolbox and this whole idea and the possibilities for you and your company. Once again, goodbye and thank you for participating today. Goodbye.
Thank you. Goodbye.
Thank you. Bye-bye.
Thank you very much.
Bye-bye.
Thank you. Goodbye.
Bye.